Well, hello guys, Mr. G here, and we're going to be doing another video for the grade 12, but this time we're going to be starting with the organic chemistry of the year. So we're going to start with the first lesson. It's going to be quite short because it's just an introduction, a few important concepts, and we'll be moving forward. We'll learn how to name compounds. We'll do all the lessons that you must learn for the grade 12. Now this one is going to be basics on representing organic molecules. I have done some of these videos last year. You can watch them already if you think I'm falling behind with the videos, because it's too much to keep on all of them. Okay, so without taking long, we're going to represent, or we're going to learn how to represent organic molecules. But the first thing we need to know is what is an organic molecule. Now guys, organic molecule is a molecule that contains carbon atoms. Now generally the carbon atom is going to be bonded to other carbon atoms as well as hydrogen. However, it could be any other atoms. Now be careful, it does not mean that all molecules that has carbon are going to be organic molecules. For instance, carbon dioxide, like CO2, it has carbon, but it is not an organic molecule. Okay, so it is important to know all organic molecules will contain carbon. Carbon is the most important atom here, but not all molecules that has carbon are going to be organic molecules. That is the first thing we have to speak about here. Now, because carbon is the most important atom in this world, we're going to be talking about carbon. Now, carbon, the symbol for carbon is letter C. Okay, and now something important about carbon. I'm not going to speak everything because I know you know a lot about carbon. I'm going to mention some important things and some very important things that you're going to be doing in organic chemistry. Carbon can form 4 bonds. So carbon can form 4 bonds, and you look here is 1, 2, 3, and 4. It can form 4 bonds, and that is very important. It cannot have 3 and it cannot have 5 or more. It can only have 4, and it must have 4 bonding. That is the first very important thing. Now, some important characteristics. Carbon can form bonds with carbon, which could be single bonding, as you can see here. This is a single bond. Single bond between carbon atoms, you can see it there. It can form a double bond between carbon. There we go, but remember each carbon must always have 4. So this is double bonds between carbon, and it can also form triple bond. So carbon can have a triple bond with carbon, and then there is the 4 bonding. This is a triple bond. You can see there between the carbon. This is triple bond. Okay, so that is the first important thing that we have to mention. Carbon can form 2 bonds. That is very important, guys. Very important, because it must always have 4 bonds. No more, no less. So it cannot have more than 4, it cannot have less than 4. It must have 4. Okay, now it can form single bond with each other, double bond with each other, or triple bond with each other. That is important. Now, when we go to organic molecules, we are going to have 2 main types of organic molecules here. So we're going to be looking at some important issues here. First of all, we can have 2 main types of chain. All right, the first one is a straight chain. For example, a straight chain could be this one. This one is a little bit more complicated than just this one, but we are going to be learning as time passes. Okay, so we cannot cover now everything. That is a straight chain. It does not have any branch. Or if you have, for instance, a double bond, it does not matter how many bonds it is between carbons, okay? But each carbon must have a 4 bonding. As you can see here, I'm counting very carefully. These are straight chains. If I add another carbon here, still straight. Straight does not mean that it's along a line, but it means that you don't have any carbon coming out of this chain. For example, that one is turned but still straight, it's still one branch, okay? Or it can be branch chain. Now, the branched chain is the one that you have a carbon coming out of the main chain, and later on, as I said, we are going to learn about main chains and so on. Now, for example, this is a straight chain, but if I add a carbon in either of the carbons that is bonded there in the middle, these become a branched. So this side here that is coming out is what we call a branch. That is a branch out of the main chain. Note the following. Because of the straight chain we spoke before here, if you add in a branch at the last or the first carbon, then it does not become a branch. It becomes like a longer one. All right. For example, in the same example as I see before here, if I add another carbon on this side here, then this one won't be a branch, because it's just making the main carbon now, instead of going there, to come here. So this is not a branch. Now, if I perhaps add a carbon somewhere here, now that becomes a branch because it's out of the carbon. So this one here could be a branch. Okay, so saying that, I hope it is understood. Saying that, be careful, you cannot have branches at the last of the first or the first carbon, okay? Always must be in the middle somewhere, but we're going to do questions about this one, guys. And the other type is the cyclic chain, but we are not going to be doing cyclic, so I'm not going to waste time speaking about the cyclic chain. Now, after we spoke about the branched and the straight chain, we are going to be talking about different ways of representing organic molecules. And let's start with the structural formula. Now, the structural formula is a way of representing all organic molecules. Now, all atoms are presented by the chemical symbol. You need all atoms with the symbol. And lines are used to represent all the bonds that are in the molecule. We are going to represent here a molecule called 2-methylpropane. So let's represent this 2-methylpropane using the structural formula. Now later on you will learn how to write formulas, how to write names. For now, all we need to know is that if we want to write the structural formula for certain compound, all the bonds between the atoms must be shown there. For example, here you have the carbons, all the hydrogens, all the atoms, guys, must be shown there. Otherwise, it is wrong. So when you finish, make sure you go back and you represent all the bonding there with the atoms. Okay, now I'm showing here a butane. Later on, as again, we're going to go back and learn how to represent the molecules, how to write the names. But for now, you need to know that if you see these structures here, as I giving you, this is called structural formula, and those are the two compounds. You have to make sure you have the bonding of each atom, and then you have to go back there, count, make sure atoms. So these are the two examples in structural formula. Let's go to the next way of representing molecules here. Now, the next way of representing molecule is going to be called semistructural formula. Now, in the semistructural formula, it is possible to understand the structure of the organic molecule. You will see how it looks like, but we are not going to write out all the bonds, only the carbon-carbon bonds. For example, and let's keep using the same two molecules we're working with. So let's write the semistructural formula for the same two compounds we mentioned in the structural formula. Now, in the first one there, you have a carbon with 3 hydrogens. So you will say CH3. We are not going to show all the bond, but now it's a bond because there is another carbon. So it's a carbon that have one H, and that carbons have a branch, which is CH3. You can see it there at the bottom. If we carry on, we have another carbon with 3 hydrogens, and this one is the same compound, but this one is using the semi-structural formula. If we represent this one here, we have CH3, CH2, CH2, CH3, and this is how we represent the structure of semi-structural formula. Okay, you show only the bonding between the carbon atoms. There is another way of representing molecule. We're almost done with this video. It's really short. Now, the other way that we are going to see is the condensed structural formula. In this case now, we are not going to show any bonds. So we are not going to show bonds at all. And let's continue to see the examples we were working with so you can see the difference between one and another. So here we have 2-methylpropane butane, we have the structural formula, we have the semi-structural formula. Now, the condensed structural formula, we are not going to show any bond. So instead of bonds, we're going to be showing just the number of atoms, but it still will look, or will show you how it looks. So now it's coming the CH that you can see here, but now there is a branch. We do not represent branches with bonding. We rather open bracket, and there is a CH3. That CH3 means that is a branch, CH3. So this one, guys, is the condensed structural formula for the same compound that we saw there in different ways: structural formula, semi-structural formula, condensed structural formula. And if we go to butane, then CH3, CH2, this one is the one I was writing before, confused, CH3. It is not difficult, but it may be confusing. Now, what you need to know, sometimes if there is a double or triple bond, sometimes it could be shown in the different structure. Sometimes it could be shown, it's not necessarily need to be this. It could be without no bonds at all, and you will have to calculate, okay? And the last way of representing organic molecule is going to be the molecular formula. Now, in the molecular formula, we are going to indicate the type of atoms and the correct number of each, but we are not going to show bonding at all. So we'll have the total number of atoms and the type of atoms, and that's it all we're going to see. So here, for example, if we want to see 2-methylpropane or butane, all we have to get is the total number of a carbon in each of them. In this case, is 1, 2, 3, and 4 carbon, and we have 3, 4, 5, 6, 7, 8, 9, and 10 hydrogens. That is the number of carbon and the number of hydrogen. This is the molecular formula for the same compound, and you will have the same number here, C4H10. You can see that there is a disadvantage. You can see that both of these molecules look the same in terms of molecular formula because they have the same number of atoms, the same number of carbon, the same number of hydrogen, but they are different compounds. So that is a disadvantage that we are going to learn next video. Please don't miss next video. This is all for now. This is the introduction of organic chemistry. Thank you for watching. Thumb up. You can ask questions. Subscribe for the channel. Mr. G here.